Welcome to Mr. Ace Math. This lesson is on comparing fractions. But before you begin this lesson, you should make sure that you're already comfortable with fractions, that you understand how to make equivalent fractions, that you understand least common multiple, how to compare whole numbers, and that you understand the comparison symbols, less than, greater than, and equal to. So make sure you're good with all of this, and let's get started. So first of all, just a brief review. What are fractions? Fractions show numbers with values that are less than one whole. And there's two parts to a fraction. The numerator, which is the number of pieces you're talking about, and the denominator, which tells you the total number of pieces in the whole. For example, let's say we have 3/4. Well, let's start off with one whole, and we're going to break that up into 4 total pieces, because our denominator is 4. And we're saying that we have 3 out of the 4. So we'll shade those 3 pieces. Here's 1, here's 2, and here's 3. This represents 3/4. How about 3/8? Well, again, we'll start off with one whole. And then instead of breaking it up into 4 pieces, we're going to break it up into 8 pieces because that's our denominator. So we'll do that. And our fraction is 3/8. So we're going to shade 3 of those 8 pieces. Here's 1, here's 2, and here's 3. This is 3/8. So let's also have a brief comparison symbol review, because that's really important. In order to be able to compare fractions, you have to be extremely comfortable with the comparison symbols. So let's take a look. This symbol, means less than. And you may not have noticed it, but it's basically an arrowhead pointing to the left, which is where numbers are lower on the number line. This symbol here is the greater than symbol. And this is also an arrowhead, but it's pointing to the right, and that's where numbers are greater on the number line. That's why it means greater than. And this one is pretty self-explanatory. It's just the equal to sign. So let's take an example. Here we have 11, and we have 8. Which symbol would we put in this circle? Well, 11 is greater than 8. So we put the greater than symbol, and it's just read as 11 is greater than 8. How about this one? 3 and 12. What symbol would we put here? Well, 3 is less than 12. So we put the less than symbol in the middle, and it's just read as 3 is less than 12. So now that we've had a review of fractions and the comparison symbols, we can start talking about comparing fractions. And we'll start with comparing like fractions, which are fractions that just have the same denominators. So there are some simple rules that you have to follow. The first rule is that the denominators are the same. But with like fractions, they're already the same. So we don't have to worry about step 1. And note, this makes the pieces the same size. In an earlier lesson on fractions, we said why the denominator was so important. It's important because it tells us the number of pieces in the whole, and it tells us the size of each piece. And the second rule is to compare the numerators. So again, after we've made the denominators the same, then we just have to compare the top numbers. So let's take a look at an example. Let's say we have 1/4 and 3/4. What symbol would I put in here to make this a true statement? Well, in order to understand exactly what's going on, I want to show you what's happening, what each one represents. Here we have one whole, and we'll have it represent 1/4. So we'll break it up into 4 pieces, and of those 4 pieces, we'll shade 1. And over here, we'll do the same thing, but for 3/4 instead. So we'll break it up into 4 pieces, because our denominator is 4, and we'll shade 3 of those pieces. 1, 2, 3. So what do you think? Is 1/4 less than 3/4? Is 1/4 greater than 3/4? Or is it the same thing? Well, 1/4 is much smaller than 3/4. So we'll say 1/4 is less than 3/4. And that's our less than symbol, and that makes the statement true. So how about this example? Here we have 7/8, and here we have 3/8. So what comparison symbol would I put in the middle to make this statement true? Well, I'm going to do it exactly the same way I did the last one. Over here, this one whole, I'm going to make it represent 7/8. So we're going to cut this into 8 total pieces, and we'll shade 7 of them. 1, 2, 3, 4, 5, 6, 7. And over here, we'll have this one whole represent 3/8. Again, we'll break it up into 8 pieces because that's our denominator, and we'll shade 3 of those pieces. 1, 2, 3. So just by looking at the pictures, you should be able to tell right away that 7/8 is much greater than 3/8. So we'll put greater than in the middle and make this a true statement. So right now, because we have like fractions, all we really have to do is look at the numerator, and that tells us how to compare them. But what about when we have unlike fractions? Let's take a look. So for comparing unlike fractions, it's going to end up being the same thing, but there are a couple of steps that we have to do before we can compare it just like we did with the last examples. Here's what I mean. There's 3 steps. The first step is to find the LCD. LCD stands for least common denominator, and it's just the least common multiple for the 2 denominators you're looking at. Step 2 is to use the LCD to create equivalent fractions. And step 3 is to compare the numerators. Because once we've used the LCD to create equivalent fractions, then all we have to do is look at the numerators, because that's really just creating like fractions. So why is this important? Because this creates pieces that are the same size. We can only compare and add and subtract fractions if we're talking about pieces that are the same size. And I tell my students that all the time. It's so important to remember that fact. That's why you're creating equivalent fractions. And that's why you're finding the LCD in the first place. So here's an example. Let's say we have 3/5 and 1/2. And I want you to see exactly what's happening in the problem. So again, I'm going to show you with diagrams. So let's say we have 3/5 here, and this whole is going to represent 3/5. So we'll cut it into 5 pieces, and of those 5 pieces, we'll shade 3. 1, 2, 3. And here we're going to have 1/2. We'll do the same thing. We'll take one whole over here, and we're going to have it represent 1/2. So we'll break it up into 2 total pieces, and of the 2 total pieces, we'll shade 1 of them. So now we've got 3/5 here and 1/2 here. But they're unlike, so we have to make sure that we follow the 3 steps. Step 1 is to find the LCD. So what's the LCD for these 2 fractions? Well, the least common denominator is 10. So now that we've found the LCD, we can use that to create equivalent fractions. So let's try and do that. How did we go from 5 to 10? What did we multiply by? We multiplied by 2. So we'll do the same thing up top to 3, and 3 times 2 is 6. And what happens is this 3/5 actually represents 6/10 as well. Because now we have 10 total pieces, and of the 10 total pieces, 6 are shaded. And how about down here? We've got a denominator of 2, and we made it 10. So how did we go from 2 to 10? Well, we multiplied times 5. And we'll do the same exact thing for the numerator. 1 times 5 is 5. And what happens is this 1/2 is now going to be 5/10 because we broke it up into 10 pieces, of which 5 are shaded. And just in case it's a little difficult to compare with all of them like this, we can rearrange it and put these 2 pieces here. And now all we have to do is step 3, where we just compare the numerators. We can look at the numerators here and here. 6 is greater than 5, and we can see from the diagrams that it's more. So since we know that this is greater, we'll put in the greater than symbol, because 3/5 is greater than 1/2. Because when we created equivalent fractions, 6/10 is greater than 5/10. Therefore, 3/5 is greater than 1/2. So here's another example. Here we have 6/9, and we're comparing that to 2/3. And we're going to do the same thing as before. Here we have 6/9. We'll take this whole, and we'll break it up into 9 total pieces, and of those 9, we're going to shade 6. And here we have 2/3. So we'll take this whole, we'll break it up into 3 total pieces. Of those 3 total pieces, we're going to shade 2 of them, because that's 2/3. And now we have to do step 1, which is to find the LCD. The LCD for these two fractions is 9. And now we're going to go to step 2. Now that we found the LCD, we can create equivalent fractions using that LCD. So how did we go from 9 to 9? Well, nothing changed. So it's really like we're just multiplying by 1. Then we'll do the same thing to the numerator, and that gives us 6. So this 6/9 stays the same. How about down here? What did we multiply 3 by to get 9? Well, we multiplied times 3, which means we'll do the same thing to the numerator. And 2 times 3 is 6. So what happens is, instead of having 3 pieces, we're now going to have 9 pieces. And of those 9 pieces, 6 are shaded. And now all we have to do is step 3. We just compare the numerators. This here is 6, and this here is 6. They're exactly the same thing. And if you look at the diagrams, they're equal. So that means 6/9 equals 2/3. So here's an example that we're going to do with just math. No diagrams, no pictures. So all we need to do is follow the 3 steps. These fractions are unlike fractions. So we need to make sure that we first find the LCD. So let's give ourselves some space to do the work. So here we have 5/8 and 2/3. So what's the LCD for 5/8 and 2/3? Well, the denominator here is 8, and the denominator here is 3. So the least common multiple for the denominators, which is just what the LCD is, would be 24. And now we can go on to step 2, which is to use that LCD to create equivalent fractions. So how did we go from 8 to 24? We can multiply by 3. And we're going to do exactly the same thing to the numerator, to 5. So we're going to have 5 times 3, which gives us 15. So here we have 15 over 24. How about down here? How did we go from 3 to 24? Well, that would be times 8. And so now we'll do the same exact thing to the numerator, 2. And what's 2 times 8? Well, 2 times 8 is 16. So now we've created our equivalent fractions, and we can go to step 3, which is just to compare the numerators, the top of the fractions. So here we have 15 and 16. Now remember, 5/8 is represented by this, 2/3 is represented by this. So we know 15 over 24 is less than 16 over 24. So that means that 5/8 is less than 2/3. Because 15 over 24 is less than 16 over 24. So here's your pause and practice. Just pause and practice. Hit the pause button, and when you're done, unpause the video, and followed by a 3, 2, 1 countdown, your answers will be displayed. Ready, set, go. Okay, so let's take a look at our answers. Number 1 is greater than. Number 2 is less than. Number 3 is equal to. Number 4 is equal to. Number 5 is less than. Number 6 is less than. Number 7 is greater than. Number 8 is equal to. And number 9 is less than. So what did we learn from this lesson? The symbol here means less than. The symbol here means greater than. The symbol here means equal to. When comparing fractions, there are how many steps? There are 3. The 3 steps are: 1. Find the LCD. 2. Use the LCD to create equivalent fractions. And step 3, to compare the numerators. By creating fractions with the same denominator, we are creating pieces that are the same size. The LCD is the least common multiple for the denominators of two or more fractions, and it also stands for least common denominator.
Don't forget to like, share, and subscribe. Questions? Comments? Leave them down below.
And thanks for using Mr. Ace Math. Don't just pass math, ace it.